Hello friends, welcome to my channel Patra Tutorial once again. And so far we have discussed about deadlock, right? So in that I have discussed what is deadlock, what is system model, and what are the different necessary conditions for deadlock. And we have already studied different methods for handling deadlock, right? Such as deadlock prevention, deadlock avoidance, deadlock detection, and deadlock recovery. Okay, so we have also studied what Banker's algorithm, then resource allocation graph, wait for graph, all those things we have discussed, right? So in this video I am going to discuss not one, only three, four questions which are related to deadlock. Okay, so let me start the first question. Okay, so this is the first question from deadlock. Okay, consider a system with n processes and a single resource R which with 6 instances. Okay, so let me write like this. There are n number of processes are there. Okay, so we don't know how many numbers are there. Okay, so n number of processes are there, it is saying, and the number of instance of resource type R is 6. Okay, and each process require 2 copies of R to complete its execution. Okay, so let me write like this, Pi. Okay, each process require 2 copies of R. Okay, 2 copies of R to complete their execution. Okay, this is the question, and what we have to find out is that what is the minimum number of processes to result deadlock. Okay, so first one, it is asking us what is the minimum number of processes. Okay, so to minimize the processes we have to allocate the maximum number of resources, right? And we have to ensure that there will be deadlock. Okay, so we have to allocate the resources, these 6 instances, in such a way that the number of processes will be minimized and the system will be in deadlock state, right? So let me allocate, suppose I have now 6 instances of R, right? So initially I have 6 instances and I am allocating one process like P1. Okay, so when the system will be in deadlock state, at least one resource, that means the process must be waiting for at least one instance. Okay, that means it will have one less than the maximum requirement. Okay, so let me allocate, because I have to minimize, right, minimum number of processes. So since I have to minimize the number of processes, I will allocate the maximum number of resources minus 1, because I have to make the system in deadlock state, right? So I will allocate, because they need maximum two number of instances to complete their execution, right? This one, so I will allocate one instances. Okay, so let me allocate one instance of resource type R to process P1. Then again I have 5 instance, right? Now let one more process came here, P2. Then I will allocate one process and I will keep this process also in waiting state. Then I have 4 resources, 4 instance. Okay, then suppose P3 came here. Okay, then I will allocate one instance of R. Then I have again 3 instances remaining. Then P4 again I will allocate one instance. I will have how many? 2 instances more left. Then P5 came here. Okay, then I will allocate one instance of R. Then one more is pending. Okay, now suppose I will stop it here. Okay, now 5 processes are there and I have allocated the maximum requirement minus 1 number of instances to each processes. Okay, now I have one instances left with me. Okay, so if I allocate this instance to any one of these process, they can continue and they can complete their execution, right? But I have to make sure that the system will go into deadlock state, right? This is the question. So minimum number of processes to result deadlock. Okay, so if I keep this one, then the system will not go to the deadlock state. So I have to allocate this instance also to another process. So let me allocate this one to P6 and I have now nothing. Okay, I don't have any instance or resources. Okay, now see, all processes are holding their maximum number of requirement minus 1 instances. Okay, and they are waiting for the next one, last one. Okay, so all are in waiting state and we don't have any more instances, right? So this system will go to the deadlock state. Okay, but if I have at least one instance more here, then I can allocate this one to this one or any one of these processes, and the allocated the process can finish their execution. Then we can allocate those resources to remaining process and continue the execution. Okay, so the maximum or the minimum number of processes we need for this system to be in deadlock state is 6. Okay, so this is the answer: 1 2 3 4 5 and 6. Okay, so the answer is 6 here. Okay, and second question, what is that? What is the maximum number of processes to ensure a deadlock free system? Okay, maximum number of process, right? So now we have to maximize the number of processes. Okay, so what we have to do is that, now again let me write here, and we have to find out n, right? Here it was 6, and now r is 6 again, and each process needs 2 instances of r to complete their execution, and we have to find out the maximum number of processes to ensure deadlock free system. Okay, so let me write again here. Suppose I am allocating one process p1 here, and I am allocating one instance to this process. I have initially I had 6, now I have 5. Okay, now p2 came here, again allocate 1, then it will be 4, then p3 came 1, then it will be 3, then suppose p4 came here, again allocate 1, and now remaining 2, then p5 came here, allocate 1, and I have one more instance here. Okay, now see, I have one instance here, and there are 5 processes are there in the system. Okay, and they all of them needs only one more instance of r to complete their execution. Okay, so if I have one more instance here, if I can allocate, suppose I will allocate this instance to p1 p2 p3 p4 or p5. Okay, suppose I am allocating to p3. Okay, I will give it to p3, so it will get 1 plus 1 equal to 2, right? And each process needs how many? 2 instances of r to complete their execution. So this process can complete now. Okay, so once this will complete, 2 resources or 2 instances of resource r will be freed, right? And we can allocate those instances to remaining processes. So if I give 1 to this one and 1 instance to this one, then this will becomes 2, and this is also 2. So these p1 and p2, these 2 processes also can complete their execution. Again they will free all the resources. Same thing will continue, and they can complete their execution. Okay, so the maximum number of resources or maximum number of processes to ensure deadlock free system is 5. Okay, so this is 5, because if I take one more, then it will go to the deadlock state. If I take p6, no, here I have to allocate this one, right? And the system will go to the deadlock state. So the maximum number of processes to ensure deadlock free system is 5. Okay, so this is the answer. Okay, now let's move to the next question. So this is the second question. So what it is asking is that, consider a system with 3 processes. Okay, now here a number of processes are given. Okay, now let me write here. Now n is given, n equal to 3 number of processes. Okay, and a single resource r. Okay, now number of instances are not given, r only given. Okay, and each process require 3 copies of r to complete its execution. And pi, let me write like this: each process needs 3 copies of r to complete their execution. Okay, now what is the first question? Let me write here. Okay, this is, I'm dividing like this. Let me write like this. Okay, so first question is what is the maximum number of instances of r to result a deadlock? Okay, so it is asking what is the maximum number of r. Okay, so maximum number of r to result a deadlock. Suppose okay, let me write like this: p1, p2 and p3. Okay, initially three processes are there, right? It is saying n equal to 3, so 3 processes are there, and we have to make sure that the system will go to the deadlock state. Okay, and we have to find out the maximum number of instances. Maximum number of instances means what? We have to allocate the maximum requirement minus 1. Okay, so let me allocate maximum requirement is 3, but if I allocate 2 here, p1 to 2, p2 to also 2 instance, and p3 also 2 instances. Okay, but their requirement is 3. Okay, so I am allocating 1 less than the maximum requirement. Okay, now how many instances I have allocated? 2 plus 2 plus 2 equal to 6. Okay, so 6 I have already allocated. Okay, and now the system is in deadlock state, right? But suppose I have one more instance. Okay, suppose I have one more instance here, there. Okay, now if I have one more instance, then I can allocate this instance to either of these 3 processes, right? Either p1, p2 or p3. Okay, but if I allocate this one instance to this one, or p2 or p1, then what will happen? If I allocate this instance to p3, then it will get 3 instances, right? Then if it will get 3 instances, it can complete its execution, because they need maximum 3 instances. And once this p3 will complete its execution, then it will release all the resources, right? And those resources can be allocated to the remaining process, and they can also complete their execution. Okay, so the maximum number of instances to result a deadlock system is 6. Okay, and the minimum number of instances of R to ensure a deadlock free system is what? 7 plus 1. Okay, if I have 6 instances, then the system will go to the deadlock state. There is a chance. Okay, but if I have one more instance, the system will never go to the deadlock state. Okay, and yes, so what is the maximum number of instances of R to result deadlock is what? 6. Okay, the answer is 6 here. And what is the minimum number of instances of R to ensure a deadlock free system is minimum number of instances is 7. Okay, so I will allocate 1 less than the maximum requirement to all the processes and 1 extra. Okay, so it will be answer is 7. Okay, so this is the solution. What is the next problem? So let me erase everything here. Okay, so the next problem is this. Consider a system with n processes and a single resource R with 6 instances of R. Okay, so here also number of processes are not given, so let me write here n equal to not given anything, and R is equal to 6 instances there. Okay, so we have 6 instances of resource type R, and each process require 3. Let me write like this. Each process require 3 copies of R. Okay, 3 copies of R to complete their execution. Okay, and the question is that, now let me write here, what is the minimum number of processes to result deadlock? This is similar to the first question, right? But the number of requirement is less, number of requirement is more here. Okay, so let me start again. So we have how many instances? 6, right? So let me allocate 1, and each process require 3, right? So I have to allocate 1 less than the maximum requirement. Okay, so I am allocating p1 to 2 instances, then p2 I will be having how much? From 6 I have allocated 2 instances, so I have now 4 instances. Okay, now p2 I will allocate 2 instances, then I will have 2 more instances. Okay, now I will allocate 2 instances to p3. Okay, now I have 0. See, I have to find out the minimum number of processes for deadlock, right? To result deadlock. So I am allocating the maximum requirement minus 1 number of instances to each processes. Okay, so p1 I have allocated 2, p2 I have allocated 2, and p3 I have allocated 2. And since we have 6 number of instances, all instances are being allocated, and we don't have anything left in our hand. Okay, now all three processes are waiting for the last instance, the next one. Okay, they need one more instance to complete their execution, right? And we don't have anything, so we cannot allocate anything to them, and the system will definitely go to the deadlock state. Okay, so the minimum number of processes to result deadlock is what? 3. Okay, so 3 is the answer. Okay, and next question is what? This is 3. And what is the maximum number of processes to ensure a deadlock free system? Maximum number of processes, it will be how many? 2, right? Because see, see, to find out the maximum number of processes, let me allocate, suppose P1 I am allocating 2 instances, P2 I am allocating 2 instances. Now I have 2 more instances left in my hand, right? So if I take one more process, okay, if I take one more process here, then what will happen? It will go to the deadlock state, right? But if I take only 2 processes, okay, I have 2 more instances, so I can allocate one to these processes, or one process to this one, then it will complete execution, then it will release everything, then again it will allocate to this one. Okay, so what is the maximum number of processes to ensure deadlock free system is what? 2. Okay, this is 2. See, you might be thinking that I have 2 more instances. Okay, so I will take one more process, P3, right? And it will allocate, I will allocate 1 to this process, and I will keep one more here, then I will allocate this one. Okay, so that is possible, but that is not always possible, right? So system may take 2 more instant, means system will allocate 2 instant to P3, then in that case it will create deadlock. Okay, so there is a possibility of deadlock free system with 3 process also. Okay, if I allocate like 2 to 1 and I will keep 1, then I will allocate this 1 to this, either P1 or P2, then system will keeps on means it will execute the processes. Okay, but that is not always guaranteed, right? So maximum 2 number of processes we can have for to ensure a deadlock free system. Okay, so this is third one, and one more question I have, so I will discuss this one. This is very interesting one, just you look at here. There are 5 processes are there. Okay, so let me write like this. P1 is there, P2 is here, okay, and P3, P4 and P5. Okay, so there are 5 processes are there in the system. Okay, and their requirement is given. Okay, their need is given. Okay, so they need how many instances of each resource is given. Okay, let me write in tabular format so that it will be easy to understand. Okay, so it is saying consider a system with 5 processes and a single resource R. Okay, only R is given, but how many it is not given. Okay, now P1 needs 4 instances. P1 needs 4 instances. Let me write here. Okay, and P2 needs 15. P2 needs 15, and P3 needs 30, and P4 needs 10, and P5 needs 18. Okay, these are the requirement. Okay, P5 needs 18 instances of R to complete their execution. Okay, then what is the minimum number of instances of R to ensure a deadlock free system? Okay, so we have to find out the minimum number of instances to ensure a deadlock free system. Okay, so number of processes are given and their requirement is given, so we have to find out how many minimum instances we should have for a deadlock free system. Okay, so let me allocate, as I said earlier in the previous problem. Okay, so let me allocate the number of instances one less than the maximum requirement. Okay, so P1 needs 4 instances to complete its execution, right? So let me allocate 3 here. Okay, I will allocate 3, and one is pending. Okay, and similarly for P2 I will allocate 14, and it needs one more to complete its execution. Okay, P3 needs 30, So I will allocate 29 and 1 is pending. And again P4 needs 10, so I will allocate 9 only. Okay, and P5 needs 18, so I will allocate 17. Okay, so with this allocation, okay, I have allocated one less than the maximum requirement of each processes. Okay, now all of them needs only one more instance to complete their execution. Okay, if I give one instance to P1, then it will complete and it will release everything, right? If I give this one instance to P2, then it will complete and it will give or it will release everything after completing execution, right? So what is the sum of all this? 14, 30, 9, 9, 18. So it will be around 70, how much? 72, right? So 4, 3, 7, okay, 72. Okay, total 72. Okay, so if I have 72 instances of R, then each processes are uh, falling short of one instance only to complete their execution, right? So if I have one more instance, then I can allocate this one instance to any one of these processes and they can complete, right? And once, if at least one process completed, it will release all the resources, right? And we can allocate those resources to remaining processes and they can also complete their execution. Okay, so 72 already allocated. If I have one more, then I can ensure that the system will never go into the deadlock state. So total we need 73 instances of R to ensure a deadlock free system. Okay, so this is the answer. I think I have explained properly and you have understood something out of this video. I don't know. So the answer to this question is what? 73. Okay, this is 73. Okay, so thank you for watching, and if you have understood something out of this video, please like, share, subscribe to my channel. Thank you.